This video is on standard AREI B3, solve linear equations and inequalities in one variable, including equations with coefficients represented by letters. This video will go over solving one-step inequalities. We need to recall our inverse operations from previous videos. Inverse operations are operations that undo each other. Addition and subtraction are inverses, multiplication and division are inverses, squaring and square rooting are inverses. We'll be using these just like we used them when solving equations. There will be some symbols, inequality symbols, used in this video. The symbols are all shown on the screen. The most important thing to remember is that the bigger number is always on the side that is open. So the symbol always looks like it is trying to eat the bigger number. There are 6 main symbols used in this video: equal, not equal, greater than or equal to, less than, and less than or equal to. When solving one-step inequalities, we use our inverse operations. You solve the problems the same way you would solve equations. There's one important rule. If you multiply or divide by a negative, the sign flips, the inequality symbol. You'll see this in some examples. Here's our first example. X plus 1 is greater than 8. We know it's greater than because it is facing the left, meaning the left is bigger. I'm going to rewrite it over here. X plus 1 is greater than 8. We solve it as if it said equals. So to undo addition, we subtract on both sides, and we get x is greater than 7. Once you have this, you can show that on a number line. What this means is every number greater than 7. Since this symbol is greater than and simply greater than, it means we cannot be equal to 7. So I'm going to draw an open circle at 7. And then I'm going to draw an arrow that points towards all the numbers greater than 7 or bigger than 7. So the arrow will go like this. It's an arrow because it keeps going. 21, 22, 23 also are included in this answer. This next example, x minus 8 is less than 12. Less than because the symbol is facing the 12, which means the 12 is bigger. To get rid of subtraction, we're going to add to both sides, and we will get x is less than 20. Again, because we are less than 20, we cannot equal 20. So I'm going to draw an open circle at 20, and then an arrow pointing at all the numbers smaller than 20. So this arrow will go to the left. You can just kind of shade that in. Next example, negative 5x is greater than or equal to 15. To cancel out the multiplication, we will divide both sides by negative 5. Now this is our special rule. We're dividing by a negative. This cancels out. We get x. 15 divided by negative 5 is negative 3. But because we divide it by a negative, we have to switch the symbol. This one is less than or equal to negative 3. So because it can equal negative 3, we're going to do a closed dot, and then all the numbers less. So I'm going to draw an arrow that goes to the left. This would work the same way for division.